In January 1918, the Fokker company presented 2 experimental prototypes of a new biplane at the first competition of prospective fighter aircraft in Adlershof. Almost all German aircraft manufacturers took part in the contest with their newest designs, several modifications of the Albatros, the Pfalz, the Roland, 2 Rumplers, 4 Siemens Schuckerts, and 1 model each from Aviatik, Junkers, LVG, and Schütte-Lanz. Fokker, in addition to the 2 main machines, also brought 2 examples of another model, as well as an improved version of his triplane equipped with a 160 horsepower twin, rotary Siemens Halske engine. The lineup of participants made it clear that the competition would be extremely intense and that choosing a winner would not be easy. The first stage of the contest took place from the 21st to the 28th of January. During this stage, leading German fighter aces, specially recalled from the front for a week, took turns flying all the aircraft presented and then reported to the jury their opinions on each machine's strengths and weaknesses. The evaluation commission was highly authoritative. Manfred von Richthofen, Bruno Lürzer, Theodor Osterkamp, Erich Löwenhardt, Ritter von Tutschek, and several other pilots, each of whom had fought dozens of air battles and achieved many victories. It is said that during the comparative flights, Manfred von Richthofen, after landing in the Fokker, evaluated the machine quite favorably, but noted one important defect: insufficient directional stability. Such an assessment from Germany's top ace could have doomed the fighter's future. Upon hearing this, Anthony Fokker and several assistants, taking advantage of the Sunday break in flying, locked themselves in a hangar and within 1 day reworked the aircraft's fuselage by lengthening its tail section and thus correcting the stability. Everything was done so cleanly that when Richthofen was offered another flight in the Fokker the next day, he supposedly noticed nothing and was very surprised that the stability had seemed unsatisfactory during his first flight. Of course, this story is more of a legend, since lengthening the fuselage in a single day, and in an unequipped hangar at that, is practically impossible. It is also impossible to imagine that neither Richthofen nor anyone else would have noticed changes in the aircraft's appearance. Most likely, the legend arose because Fokker had brought 2 nearly identical aircraft, and on the second one, the stability issue had already been resolved. Apparently, Richthofen simply flew these 2 planes one after another and gave them corresponding evaluations. The second part of the contest, which concluded in mid-February, consisted of precise measurements using control instruments to determine the maximum speed and rate of climb of the competing aircraft. This stage was conducted without participation from frontline pilots, and the factory test pilots continued the trials. Aircraft with inline water-cooled engines were evaluated separately from those with radial rotary and twin rotary engines. According to the instrument readings, the Rumpler, a small, elegant airplane with exceptionally clean aerodynamic lines, demonstrated the highest speed and rate of climb. The Fokker took second place, and compared to its main competitor, it looked rather unattractive, larger, more angular, with rough, chopped contours. However, these external shortcomings came with several advantages. The Fokker was more technologically practical, cheaper, and easier to manufacture than the Rumpler. Under conditions of Germany's economic blockade and the shortage of skilled labor, this was extremely important. Furthermore, frontline pilots unanimously noted that the Fokker was much easier to fly and more stable in all 3 axes. Taken together, all this made the Fokker the clear leader, especially since the Rumpler's advantage in flight performance appeared extremely small. Be that as it may, the aircraft from the Fokker company, which outpaced all competitors, was accepted into service by the German Air Force. This aircraft fully matched the prototype except for a slightly reduced and newly triangular fin. In addition, it was equipped with the standard armament of all German fighters of the time: 2 synchronized Spandau machine guns. The situation began to change in 1917, when the Austrian banker of Italian origin, Camillo Castiglione, bought out the small Munich plant Rapp, investing a substantial amount of money into its expansion and modernization. The plant received a new name, Bayerische Motorenwerk, which means Bavarian Motor Works, abbreviated as BMW. The enterprising banker did not hesitate to spend money to lure several leading engineers and designers away from Daimler by offering them higher salaries. Soon, the first successful development of the new design bureau appeared, the engine with the index 3A. In its construction, it resembled the Mercedes engine with the same index in many ways, but it had a number of important improvements that made it possible to raise the power from 160 to 185 horsepower. But its main highlight was the so-called altitude compensator, a device that adjusts the fuel mixture depending on air density. This device allows aircraft engines to partially compensate for power loss as altitude increases. Thanks to it, the BMW engine could deliver 155 horsepower at an altitude of 13,000 feet and 120 horsepower at 20,000 feet. The new engine was experimentally installed on one of the production Fokkers, and on the 25th of April, a test pilot named Nuisen made the first flight in this machine. The fighter's behavior and vertical maneuvers amazed the aviator. "The aircraft with this engine is very good," Nuisen wrote in his report. "It gains altitude quickly and steadily at an extremely steep angle. At times it seems that the machine is simply hanging on the propeller." Instrument measurements of speed and climb rate produced excellent results, fully confirming the pilot's assessment. In horizontal flight, the machine surpassed the mark of 124 miles per hour, and it reached an altitude of 20,000 feet in 20 minutes. For comparison, at the competition in Adlershof, the Fokker with a Mercedes engine needed half an hour to reach an altitude of 16,400 feet, and that was considered a very good result. The ceiling of the fighter with the new engine also increased significantly, reaching a very impressive figure for that time, 24,600 feet. Fokker's main competitor, the Adlershof company, also tested its fighter with the new engine. The characteristics of the machine improved, but in the modernized 7 with the BMW engine, they were higher. Therefore, the Aviation Inspectorate ordered that the entire production of these promising engines be allocated exclusively to the 7. There were simply not enough of them for fighters of other types. Mass production was expanding slowly, and by the end of the war, Bayerische Motorenwerk managed to produce only 637 units. Because of this, most production Fokkers initially had to be equipped with Mercedes engines. In May, only 13 fighters with the new engines were built. In June, 28. In August, 40. Only in the final months of the war were most 7s equipped with BMW motors. Since these fighters were rightfully considered high-altitude machines, they were the first in the world to be equipped with oxygen devices. Under the terms of the Treaty of Versailles, Germany was forbidden not only to have a military air force, but also to produce combat aircraft. Learning of this, Fokker decided to move his aviation empire to his homeland, the Netherlands. Throughout 1919, a total of 350 railway wagons loaded with machine tools, equipment, semi-finished products, aircraft engines, and other property crossed the German-Dutch border. This made it possible to establish production in Amsterdam at the new company Nederlandische Vliegtuigfabriek. One fighter for some time was used as the personal aircraft of the Chief of Aviation of the Leningrad Military District, and 3 more were transferred to the first higher school of military pilots in Moscow. In September of 1922, the head of the school, Mykola Petrovich Ilzin, was killed on one of them. His fighter collided with a plane flown by a cadet. These aircraft belonged to the Combat Application Squadron, where Mikhailo Mikhailovich Hromov served as an instructor. In January of 1925, the 3rd Fighter Squadron received an order to hand over its aircraft and begin mastering more modern machines. A little later, a similar order was received in Gatchina. The old 7s that could still fly were used to equip separate naval and fighter detachments. The first was based in Peterhof, the second in Yevpatoria. After the naval aviation was incorporated into the air forces in 1927, these detachments were renamed. At that time, the Soviet air forces had a total of 37 such aircraft, which amounted to about 1/4 of all fighters, of which there were still very few. In 1928, one of the detachments received domestically produced fighter biplanes. By 1927, the old aircraft built 10 years earlier were already badly worn. In the machine logbooks, notes such as "service life expired" began to appear, and in repair referrals they wrote, "due to wear." The fabric on the wings was repeatedly replaced and the engines were changed. Importing engines had already stopped, and it was necessary to rely only on repeatedly restoring the old ones. Accidents due to engine failures occurred one after another. On the 31st of October 1927, 2 machines crashed in one detachment, and in one of them the pilot, Matveyev, was killed. Things then became even worse. Only between July and September of 1928, 8 accidents occurred in this detachment. Wheel tubes burst, cowling panels opened in flight, radiators leaked, and control rods broke. Despite this, the detachment continued combat training, including participation in joint exercises with other units and anti-aircraft artillery. On the 15th of April 1929, another catastrophe occurred in the detachment. The aircraft flown by flight leader Volodymyr Sukharev failed to recover from a spin. That same year, this detachment was disbanded. After that, no combat unit fully equipped with such aircraft remained in the Soviet Air Forces. These planes never took part in any combat operations. From the early 1930s, the aircraft that could still fly were used as training machines in various aviation units. 1 or 2 aircraft for this purpose were held by several squadrons and aviation detachments. For example, in 1930, one entire detachment flew domestic fighters, while its only old aircraft served as a liaison and training plane. Such aircraft continued to be operated in military flight schools as well. By 1931, only a dozen aircraft from the original 50 German biplanes remained. 3 of them were given that same year to the Aviation Support Society. In one aviation brigade in Ukraine in October 1931, 3 machines were listed, 1 each in 2 detachments and 1 unserviceable in storage. By the end of 1932, only 4 such aircraft remained in the Soviet Air Forces, and by December of the following year, only 1, which was soon written off. From the summer of 1925, a secret German flight school operated in the Russian city of Lipetsk. It was disguised as an ordinary training unit of the Soviet Air Forces. The Germans called it simply the station, or the Scientific and Testing Aviation Station. Aircraft were brought from Germany for this school. The main fighter there was the Fokker of the 13th model, but documents from 1926 to 1929 also mention 1 or 2 aircraft of the 7th model. When the Germans left Lipetsk in September of 1933, they abandoned their outdated aircraft, but not a single Fokker of the 7th model was among them. Most likely they had been scrapped earlier. It is interesting to compare this German fighter with the enemy aircraft that also appeared in 1918. All of them were roughly the same size and weight, and all had 2 wings. The armament was also identical, 2 machine guns of regular caliber. The only exception was the French aircraft, on which engineers removed one of the guns to save weight. The German fighter was not the fastest among them. The version with the Mercedes engine in particular looked rather average. The reason was the insufficient power of the engine. Almost all new British and French fighters had engines rated at 200 horsepower. The greater thrust provided better flight performance. The Germans did not have such a motor. Even their best engine produced only 185 horsepower. But the German fighter, unlike the fully wooden British and French aircraft, had a metal fuselage frame and was designed for a high margin of structural strength. Therefore, the Germans focused on maneuverability, both in the horizontal and vertical planes. The structure did not fail even during very abrupt control inputs. Adding to this was the high effectiveness of the control surfaces and the aircraft's obedience to small pilot errors. This fully matched the air combat style of that era. At the same time, the advantages of the German fighter increased with altitude. As a result, it became a very dangerous combat machine for the enemy, one that fully earned its fearsome reputation. The fighter is a single-seat aircraft with 2 wings and a mixed structural design. The fuselage is a welded frame made of thin-walled steel tubes with a diameter of 1.3 inches for the engine mount, 0.9 inches for the main longerons, and 0.8 and 0.7 inches for the connecting struts and braces. Additional structural rigidity was provided by internal cross-bracing made of steel wire with a diameter of 0.07 inches. Behind the cockpit cutout was a plywood turtle deck that gave the upper fuselage a semicircular shape tapering toward the stabilizer. The covering of the forward fuselage consisted of partially removable aluminum panels, and the rest was fabric. The fabric covering was sewn to the frame with strong thread, and then the seams were taped with Aerolac-soaked strips. The assembled fuselage frame weighed only 99 pounds. At the nose of the fuselage, a 3-section automotive-type water radiator was mounted on top. On the left side, it had a filler neck. The radiator could be removed without taking off the propeller. Behind it was a 6-cylinder inline Mercedes or BMW engine, almost entirely enclosed by a cowling. Only the valves and cylinder heads remained exposed. The side panels had access hatches for engine components and pressed openings for additional cooling. In hot weather, the top cowling panel was usually removed to avoid overheating, although this slightly worsened the aircraft's aerodynamics. Exhaust gases from the cylinders were directed into a manifold with an outlet pipe on the right side. The propeller was wooden, two-bladed, and of fixed pitch. Behind the engine was a fuel tank with a capacity of 24 gallons divided into two compartments, the main tank of 16 gallons and an auxiliary tank of 8 gallons, as well as an oil tank mounted on the right side. There was no oil radiator. Two synchronized Spandau machine guns of 7.92 millimeters caliber were mounted openly on top of the fuselage in front of the pilot's cockpit. This again worsened the aerodynamics but improved cooling and made the weapons easier to service during flight if a jam occurred. The guns were reloaded manually. Ammunition was fed from cloth belts stored in metal ammunition boxes. The ammunition load was 500 rounds per barrel. The gun sight was the simplest type, a ring and bead sight or a telescopic sight similar to the British Aldis. The pilot sat in an open cockpit. The cockpit opening was trimmed with leather. For easier boarding, there was a footstep on the left side. The cockpit equipment looked very primitive, which, however, was typical for aircraft of that period. Most machines did not even have an airspeed indicator or an altimeter. The instrument panel usually carried the engine tachometer, the fuel and oil pressure gauges, the magneto handle, and the valve for switching the fuel supply between the main and auxiliary sections of the fuel tank. On the right side of the cockpit were mounted a compass and a hand-operated fuel pump, and on the left side, the throttle quadrant. The aircraft was controlled in a classical manner and with a control stick and rudder pedals. The control linkages to the rudders and ailerons were soft cable lines. The control stick had machine gun triggers. The pilot could fire either from both barrels at once or from each one separately. Machines equipped with BMW engines were fitted with oxygen devices. They consisted of a cylinder with a valve and a reducer in a lattice protective casing, an inflatable reservoir bag, and a rubber hose with a mouthpiece that the pilot took into his mouth whenever necessary. The wings were entirely wooden, with two spars of simple rectangular shape with slightly rounded tips. The span and the chord of the upper wing were greater than those of the lower one. Ailerons with horn compensation were mounted on the upper wing. In construction, the upper and lower wings were similar. Their airfoil thickness and the width of the spars decreased from the center section toward the tips. The spars were box-shaped with pine flanges and plywood walls about 0.06 inches thick. The ribs were also made of plywood about 0.06 inches thick, with edging strips roughly 0.2 inches thick. The rib spacing was about 12 inches. In the areas where struts, braces, and ailerons were attached, the ribs were reinforced. Inside, the wings were braced with crossed wire tensioners stretched between the spars. The leading edge of the wing up to the front spar was reinforced with plywood about 0.05 inches thick, curved to the airfoil shape. The covering of the remaining surface was fabric. The ailerons had a metal framework of tubes and were fabric covered. The struts and interplane struts were made of tubes with a teardrop-shaped cross-section. By the way, the characteristic N-shaped struts that worked in torsion, which made it possible to eliminate bracing wires between them, were patented in Germany by the enterprising Anthony Fokker. Later, such struts were used on many other biplanes around the world. In particular, they can be seen on the famous Po-2. There were no diagonal bracing wires in the biplane box. The tail unit had a classical layout with a single fin. The horizontal stabilizer was supported from below by struts and connected from above to the fin with bracing wires. The control surfaces had horn aerodynamic compensation. The fin could be installed at a slight angle to the aircraft's axis to compensate for the gyroscopic effect of the rotating propeller. The framework of the tail unit and control surfaces, like the fuselage frame, was fully welded from steel tubes but of a much smaller diameter. The covering was fabric. The landing gear was a three-point arrangement with a classical cart made of tubes and a wooden tail skid. The wheels were spoked approximately 30 by 4 inches in size. To reduce drag, the spokes were covered on top with fabric. The wheel axle was solid and was enclosed in a large wing-shaped plywood fairing, which formed an additional lifting surface of about 10.5 square feet. The rigidity of the landing gear was increased with crossed bracing wires. The wheel shock absorbers were rubber cords, and the tail skid had either the same cords or thin cylindrical coil springs.